Okay, in CalcBC, we've got our Chapter 7 review for the quiz. Important to point out that the rest of these problems aren't going to be on our Chapter 7 quiz that we have this week, but all the same, these are problems coming up, the next few of them that relate to inverse trig, and that is very, very important. First of all, just a real brief reminder about inverse trig. Number 11 looks something like, and I think most kids would agree, it looks vaguely like this thing right here, 1 over the square root of a squared minus u squared. Granted, it's more complicated than that. But that was inverse sine of u over a plus c. And when you're working these out, what you want to do first and foremost is to write this in the proper way where you're going to have a squared term. This would be a 4, but that's 2 squared. We need to have something squared over here, e to the 6x. Well, that's really like e to the 3x that's being squared down below. And why do we do this? Well, it's definitely going to help us find out what a good u substitution is going to be. We could right now maybe let u equal e to the 3x. And du, of course, would be e to the 3x times a 3 with the chain rule, dx. And then dx would be du all over 3 e to the 3x. Well, this integral, I think you can see pretty quickly, is going to greatly simplify then. This right here will be just u squared. Dx becomes du all over a 3 e to the 3x. And hopefully you can see that this e to the 3x and this e to the 3x is going to go away. I hope you can also see that we could just as well pull that 1/3 out, and then really we're left with this very nice, much simpler looking problem right here. Well, you can see what I was pointing out earlier in regard to the review that we had. We said, look, in general, and I'm highlighting this in blue here, this is what an integral involving inverse sine is going to look like. So don't forget, we still have our 1/3 out in front. This will become then inverse sine. I hope you can see this. It's going to be u over 2 plus a constant. But here we go again. We're evaluating this algebraically. So we'd like to have an answer with x in it. So I'm just going to resubstitute in that u there is really e to the 3x. So we have e to the 3x all over 2 plus a constant. And we are done. Okay, as we are taking a look at number 12, maybe just going off to the side, what we saw in a recent lesson is if I had 1 over a squared plus u squared du, that was actually equal to 1 over a inverse tangent of u over a plus c. Now, I'm bringing that up just because I'm seeing squared terms in the denominator. As I'm coming over here, we can very quickly focus on that denominator and say that's a 4 squared. Here's a cosine of x squared. And yes, it doesn't look quite as direct as what we saw over here. But the bottom line is, once you've separated that and you've written it as your squared terms down below, we could let u equal cosine of x. We're getting a lot of help, and honestly, that's why u is used in there. It's going to be our u substitution. du would be negative sine of x dx That means dx would be du all over a -1 sine of x. If you'd like, you can bring a -1 out there. And our bounds are going to change. You know, when I plug in a 0 for cosine of 0 is a 1, as I'm going to change to working this out with u. When I plug in pi over 2, cosine of pi over 2 is actually a 0. So this is going to get cleaned up very, very fast. You know, our dx, like we just said, is really a du all over a -1 sine of x. So the sine of x's are going to cancel out. And I'll tell you what, this -1, maybe you'd like to apply it to this integral and change the bounds. Change it to go to 0 to 1 and get rid of that -1 down below. And then look at that. This works out very, very, very fast. Now, following this pattern that we see up here, you could say, well, now it looks exactly like this. We can say 1 over a. Well, our a is a 4. And I'm going to say inverse tangent of u over a. So that's u over 4. But this time we're going to be plugging in a 1 and a 0. Now, when you plug in the 1, you'd have inverse tangent of 1/4, which we actually can't even work out. We don't know what angle that is, and that's okay. Inverse tangent of 0, what angle would give a tangent value of 0? Well, the answer is 0. That just wipes out. But just wanted to point out that it's perfectly okay to come up with an answer like 1/4 inverse tangent of 1/4. We'll stop here and then finish up with one last video on the last page.